you can't convert until there's no constant in front. So you got to get that 3 out of there. How do you get that 3 out of there? You divide. So you got to do that first. And so you get log base 8 of 2 equals 1/3. Now you convert to exponential form. So now I can say my base is 8. My power is 1/3. And that equals 2. Now, do you guys understand why that's true? Okay, what does the 1/3 power mean? It's your cube root. Now, when I say do you understand, more so than just typing in your calculator. Okay, yes, you can type in your calculator and it'll spit out and validate yes or no, but I want to make sure you understand for when we move forward. So that is saying, that would be the answer. 8 to the 1/3 equals 2, but that's saying the cube root of 8 equals 2. All right, same thing. Make sure we know our fractional powers, how they're related to the root boxes. Okay, 1/3 is cube root, 1/4 is fourth root, so on and so forth. All right, that's 29. All right, good question. What is it?
39.
All right, 39. Good. I was hoping somebody would say 39. And then we'll look at 41 as well because it's on the same lines as 39. All right, log base 3 of square root of 27. All right, it's saying what 3 to what power equals that? I don't think that's obvious. Okay, I don't think like you just look at it and say, oh yeah, I know exactly what that is. I know log base 3 of 9 is 2 because 3 squared is 9. But 3 to what power is 27? So if you're not quite sure, this is where I throw in that x and I say 3 to what power equals the square root of 27. For these ones where there are no calculator, like you can't type this in your calculator Monday, you got to think common base. How can I get each side to the same base? 27 can be written as 3 to what power? 3 to the third. So I'm going to write that as 3 to the third. So this is 3 to the x equals square root of 3 cubed. All right, now sometimes we want to get rid of the square root. You can get rid of the square root by making it a power. Square root is what power? Okay. Now second, 1/2. Make it 1/2. Okay, so it's 1/2 power. So I can make this 3 to the x equals 3 cubed to the 1/2 power. That's an interesting looking 3. And so we basically want to get this as 3 to a power equals 3 to a power. Then this is where all our little rules come into play. We still got to know them. What do we do? Power to a power? Multiply them. So 3 times 1/2 is 3/2. So once you get this, you can say x equals 3/2. All right, x equals 3/2. Now a lot of times you think about it differently. Did anybody do this a different way? What'd you do?
I squared both sides to get rid of the square root, so that way it was like 3 to the 2x equals 27. And then,
but you were right here at this point? Yeah. Okay, good. So all right, she said, all right, I'm going to get rid of the square root. I'm going to get rid of the square root. I'm going to square both sides. When you do that, all right, key thing you got to watch here, because I think it'd be common, like, that's not x squared. Because you got to follow your rules. So you're multiplying those two together. So what's it going to be? 2x. And that's going to be 27. And then where'd you go from there?
I just simplified 27 to the 3 to the
third?
Yeah.
Okay, so
just kind of did 2x equals 3.
So at least that part was the same where you made them common bases. Okay, so we ended up getting the common bases. She got rid of the radical. By squaring both sides, I got rid of the radical by making it 1/2 power. Either way, helps get rid of the radical. So now I get 2x equals 3, x equals 3/2. All right, Justin, you do something different or something?
Yeah, I just thought about it. So I knew it needed to be 27, so that was 3 to the third. And since it's a square root, it'd be times by 1/2. The exponent would be 1/2, so I just multiplied 3 times 1/2.
Okay, so you just kind of did it intuitively. Okay, so not everybody can just think about it and just say, oh yeah, that's 3/2. Okay, so me, I can't do that. I got to do this. I got to do paper cuts. Okay, on now. All right, 41. Take a look at 41. Let me go to here. And let's see. Log base 16 of 2. Log base 16 of 2. So this is saying 16 to what power equals 2? Okay. 16. It can't be the first power, can't be the second power, can't be the third power, because those would all be bigger than 16. So 16 to the x. This is again, I want you to go common base. Can 16 be written as 2 to a power? Yeah, 2 to the 4th. So 2 to the 4th power, all to the x equals 2, and that's 2 to the 4x equals 2, and you can think of that as 2 to the first. This is where we get 4x equals 1. X equals 1, 4. Okay, for that. All right, other questions? 51. Oh, good one. All right, 51. 2 to the log base 2 of 7. 2. And then plus log base 5 of 5 to the negative third. All right, those go to the properties that we went over yesterday. If you got a base, okay, and then you're taking log base to the 2, the same thing of 7, what does that end up equaling? Yeah, this whole thing, when it's the same base, just 7. 5, log base 5 of 5 to the negative third, that's going to end up equaling what? Negative third, but you just got to do 7 plus negative 3. So this is a little bit totally different than this one where you're taking the power. We're just using those properties. So it's just 7 plus negative 3, 4. Okay, but you got to know those rules. All right. What else? Nothing else yet? Okay, to keep your homework right out, just tack this on there out of the book. I want you to do 93 through 98. 93 to 98. A little bit similar. We'll do. I think I'll flip the page over. No calculator. And your answer will always be a constant, a number. Maybe a fraction, but it'll be a constant. 1/2, 2, -6, 4. On there. So there will not be a log in your answer. This is what I'm trying to say. And if you're really stuck, just move on. Like we'll go over. Just come back to it. right, I'm gonna read the answers real quick and then we'll go through because I see some of you are kind of getting off on some tangents. So if you get the answer right, you're good. All right, first one, 93. Should be 1 when you're done. 93 is 1. 94 is 0. 95 and 96 are both 2. Okay, final answer is 2. 97 is 4. 98 is 6. Okay, so you got it. All right, let's take a look at that first one. Like I said, if you get off on the wrong tangent, it's hard to see what's going on there. You don't need that. All right. Marissa, what's 94? Log base what?
4, and then in parentheses, log base 3 of 81.
Now we've talked about, setting it equal to x. You can do that. That's fine. But one thing we can also do, you kind of got a complete log right here in this parentheses. We kind of got to work inside out. Start with the innermost parentheses and work out.
That's 93.
Oh, I want to do 93. Sorry, I need to change. That should say 93. Whoops. I did want to do 93. I just wrote 94. Okay, so you look inside that parentheses. Can you figure out what that is? What is log base 3 of 81? 3 to what power is 81? 4. 3 to the 4th power. So that can be replaced with a what? 4. It's gone. So this right here, log base 3 of 81 equal to 4. So now this becomes log base 4 of 4. Okay. Well, now that says 4 to what power equals 4? 1. That's where we get the 1. Okay. So now our answer is, like I said, it's a constant. It's not log base 4 of 1. It's just 1. So here at this point, now you could set that equal to x and kind of work through that. You'd eventually have to get to the 1. Kind of do the same thing with 94. Same thing with 94 as you're working, because you got several bases on there. So we got log base 4 of log base 3 of log base 2. Log base 4 of log base 3 of log base 2 of 8. So you got all that going on. We kind of got to start, like this is, like I can't figure this out yet because I don't have a constant. I got log base 2 of 8. I can figure that out. 2 to what power equals 8? That would be 3. So that gets replaced with a 3. Log base 4 of log base 3 of 3. So now you're going to evaluate that. Log base 3 of 3. 3 to what power equals 3? That would be 1. So I got log base 4 of 1. This is one of our rules. Sometimes you overlook it, but you're basically saying 4 to what power equals 1? Well, that's always going to be what? 0. 4 to the 0 power equals 1. So 0. Okay, so we got that. Now the next 4 are all kind of similar because you got radicals in the base. Okay, so I think if we can get one of them, we can get the others. But so for 95 log base square root of 2. Is it equal to? Or no, log base square root of 2 of 2. Correct? Is that it?
Yeah.
Okay. So now we're saying, all right, we got a radical here. So square root of 2 to what power equals 2? Okay. And so you got to be careful here. So this is the radical. We can either get common bases. If you get rid of this, you can square it like Anna did with the other one, which I kind of like that. Or I can get rid of the radical by making it what power? 1/2. So this is 2 to the 1/2 all to the x equals 2. And so now that's 2 to the 1/2 x equals 2 to the first. And so really I got 1/2 x equals 1, divide by 1/2, or however you do, multiply it by 2. I end up with x equals 2 for that one. Okay. And so that would be that final answer on those.
The way I did, I still got the right answer. But
Okay.
I solved it if I put 2 in because it's just a square root that 2 would equal 2. Is that a bad way to think of it, or?
Well, this is easy because sometimes people say, well, if I take this and I make that 1/2, then that's going to be the same. Maybe say how you did it again.
I just saw that it was a square root and they both had 2's, and I just said 2 would get rid of the square root.
Okay. No, that worked.
Okay.
Because if you get rid of the square root, you wanted to make it 1. Now that wouldn't work exactly the same for like 97 or 98. I mean, you got to do that. Let's take a look at 98. 98. What do we got there? Log base
Square root of 3.
square root of 3 equals 27. So that gives why do I keep putting equals in there? Log base of 27. So square root of 3 to some power equals 27. Okay. In terms of that. Well, if you square that, I think this is what you're doing. Then that makes that just a 3. I think that's what you did on the last one, right? Okay.
I still got the right answer.
No,
But
you're okay. I didn't say you
no,
did
like
anything
on
wrong.
this one too.
So,
I just. So I. How do I explain it? So I said there was a 6 there
a 6.
because
Oh, for the x.
yes, because the 2 gets subtracted from it and the 1, and then you just count up.
So you're kind of doing the things mentally.
Yes.
So this,
It's hard to explain it.
that's 3 to the 1/2 to the x equals 3 cubed. Well, this just gives you a little bit more structure. I'm just going to set that up. Some people need that structure. Some people can think about it differently, which is fine. So really, you get 3 to the 1/2 x equals 3 cubed, and you're essentially saying, all right, what does that need to be to make that 3? It'd be 6, or you can just go 1/2 x equals 3, divide by 1/2. We still get x equals 6. Okay. All right, so setting that up with a little bit different bases, like a radical and a base, and something that may not be just, log base 2 of 8, not just a whole number. So I want to do that. All right, look at 111. We're going to do that together. That's the problem we're going to have to know how to do. 111. Over there on that right-hand side. All right, everyone wants to double their money. Everyone wants more money. So doubling your money. How long would it take to double your money if you invested P dollars at the rate of 8% compounded continuously? Now, if you look above there, it says in exercises 111 through 124, use those equations. Well, when it talks about continuous compounding, I'm going to use A equals P times E to the RT. It's just a different form, but it's that same equation. All right, I'm not going to worry about what they have up above there. I'm going to use that. All right, so we want to see how long it takes. Now, I want to talk about something before we go to this equation. If you have, and I'm just going to make this up here, 6 equals e to the m power. What does that look like? How do you write that in terms of logs? How do you write that in terms of logs? Like, just rewrite that. Okay.
Natural log of 6 equals m.
Natural log of 6 equals m. Correct. Okay, that's what we do. What if I have 3/4 equals e to the 5x? What would that look like?
Natural log of 3/4 equals 5x.
Okay. Can you solve that for x? Can you use now here you're allowed to use your calculator. Can you use your calculator to get the natural log of 3/4? Can you divide by 5? So you can figure out what x is. So this is a way to solve for a variable in the exponent, which is what we're going to have here. All right, let's take a look at this example here for 111. So A equals P times e to the RT Compounded continuously. That means you have to use this format. You can't use like the 1 plus r over n. That's for compounded quarterly or compounded monthly. All right, is it 8%? We want our money to double. Well, I don't know how much is, so how do I represent that at least? 2p. So whatever p is, we're going to double it. So 2p equals p times e to the 0.08t. Before you can convert something to natural log form, you got to get the e by itself. So I got to get rid of the p. Divide both sides by p. And you're just left with what on that left-hand side? 2. Now you got to think, if you're doubling your money, that should always be the case, because if you started out with $10, you're going to end up with 20. If you started with 40, you're going to end up with 80. When you divide by that number, you're just going to get left with 2. All right, now this is basically what I was talking about over here. Once you get to this point, kind of stuck until you convert it to natural log form. Natural log form, what's it going to look like? Natural log of what? 2 equals 0.08t. So the natural log of 2 equals 0.08t. Now use your calculators. Now you round to the nearest hundredth. I think that's what my book says. Nearest hundredth. How many years would it take to double your money? Doesn't matter how much you started with. You started with $1 million or you start with 100.
8.66 years.
8.66 years. So t divided by 0.08 divided by 0.08. T equals 0.8. 8.66 years. All right, so that would be the case. 8%. That's a pretty typical average. There's a little bit of like finance. There's a little bit of rule. I think it's called the rule of 72, but it's usually around 7 or 8 years. You know, with a decent interest rate, your money should double. So every 7 to 8 years, your money should double. So if you're starting with 50,000 in say 8 years, it should be what? 100,000, and then another 8, it should be 200,000, and then another 8, it should be 400,000. So that's the doubling effect. Okay, so there's a principle for that. All right, you do 112. You do the next one. Do 112. And round it to the nearest hundredth. And you notice, like in all of those problems there, they're all compounded continuously. Okay, so we use that A equals P times P to the RT equation.
Are you on superman square? What's that? So it's the natural log to the superman square? Yeah, usually we write the E. You're used to the E. It's too long. TS are too long.
Equals 1 C equals 1.
And then
I recommend it.
Split up four. So yeah, if you put it in.
Yeah, I tried it.
This time here, you've got your mindset.
Well, still like 30.
And then that cancels that too.
That's good. Italian place.
Yeah, that makes sense.
If I could actually have a chance to do it, it would have
Yeah.
I don't know why. I didn't understand.
That was a contributing factor.
Yes.
24.85, right?
Yep.
So you what's the amount? A equals P times E to the RT. We want to end up with 120,000, right?
Yep.
And we're starting out with 10,000. And then 10%, right? So now you gotta divide first. Divide by 10,000, and let me write it out. Divide by 10,000. Divide by 10,000. I get 12 equals e to the 0.1 or 0.10 t. Now you got to convert that to ln. Okay, so we say the natural log of 12 equals 0.1 t. I said it yesterday. Answer to a log is always a exponent. Same thing with natural log. So that's why it has to equal that exponent divided by 0.1. Here, 0.1 divided by 0.1, so t equals, this is here where we say natural log of 12 divided by 0.1, 24.85. What's the natural log of 12 asking?
E to what power equals 12?
E to what power equals 12? Okay, make sure that says E, Euler's number. So E to what power equals 12? Okay, that's what we're saying. So it's got to be somewhere in between like 2 and 3. Because E squared is like 7.4 and E cubed would be more than that. Okay, so somewhere in there. So make sure you kind of understand that. And right now we can't figure that out without our calculator, so we use that. All right, let's go. We were going to talk about Newton's law of cooling, which I know everybody's kind of anticipating. We're going to table that until after the quiz. Okay, we're going to table Newton's law of cooling because I want to make sure I give you some time in class to work on this review. I'm going to pass this out. It'll be pretty clear which ones are calculator, which ones are non-calculator. You may work with somebody on this. This rule does need to be turned in and worked on until the end of the period. T Swift?
John is
After music.
I
graduated my phone.
Sure.
They got they got it? No, I never asked.
My favorite one in the album is John.
Do you?
No,
I don't know.
I don't know.
Yeah, exactly. That's
I mean, he was explaining physics to the sign over there the other day. I was wondering if he took it.
Physics?
Yeah.
Oh, yeah.
But he just
Who's next?
I mean, I would.
Let's go. Katie's got a hand up.
Okay.
So it goes digging, and then it's for let's then speak now, then red, then 1989, then vegetation, then And folklore, and then Taylor version of Fearless. I don't know the singles, like where the